Special right triangles. There are two types of special right triangles. There's what's called a 45-45-90 right triangle, and then there's also a 30-60-90, and that just means that you have a right angle with one angle 30 degrees, another angle 60 degrees. Special right triangles are called special right triangles because you only need to have one given side in order to find all the other sides. So unlike Pythagorean theorem, with Pythagorean theorem, remember we had to have two sides, let's say 3 and 10. And then we would have to have those two sides in order to find the third side. Well, special right triangles are special because there's only two of them, and they can be used to find any of the sides given only one side. Okay, the first special right triangle that we're going to talk about is the 45-45-90 triangle. And in a 45-45-90 triangle, the hypotenuse, so the side across from the right angle, is going to be square rooted 2 times as long as each leg. So this hypotenuse, let's just say each leg was the variable n. The hypotenuse would be square root of 2 times larger than the leg n. Okay, so when you're given a special right triangle, and the way to identify it is to find each missing angle measure. So you have 90 degrees here, 45 degrees here. Subtract those two from 180. You're going to get 45. So this is a 45-45-90 triangle. Now in order to find one of the missing sides, we do just like we had labeled up here. We label each side as n, and n square root of 2. So the side opposite 45 is equal to n. The side opposite the 45 is equal to n. The side opposite the right angle is equal to n square root of 2. Our next step is to locate the side that has a number next to it. So there's two of them. There's this side and there's this side. And use that side to solve for n. Well, when we say solve for n, we wanted to say n equals. That's our goal in each of these problems, is to find out what n equals. And in this case, we see clearly that n equals 5. N equals 5. Now that we found the value for n, we want to replace every n we see with the value that we found for n. So we replace this n right here with the value 5. So that gives us our solution that x is equal to 5 square root of 2. Okay, so let's try that again with this first example. We want to label each side as n, and n square root of 2. Well, first of all, we know this is a 45-45-90 because if one's 45 and the other one's 90, what's left over is 45. So because it's a 45-45-90, here's our steps. Label each side as n, and n square root of 2, but make sure you label them correctly. Opposite the 45 is equal to n. Opposite the 45 is equal to n. Opposite the 90, the hypotenuse, is equal to n square root of 2. Now we want to locate the side that has a number next to it. So as you can see, 16 is the side with the number next to it. We're going to use that side to solve for n. So the equation that we're given in this case, it doesn't say n equals. It says n of square root of 2 equals 16. So we want to solve for n using this equation. N times the square root of 2 is 16. So all this is saying is n times the square root of 2. So in order to undo the multiplication here, we need to divide both sides by the square root of 2. That's how we're going to isolate our n. Square root of 2 over square root of 2 is 1, so we have n equals 16 over the square root of 2. So we have successfully found n. So we use that side to solve for n. Our last step is to replace every n with the value that we found for n. So I come over here with my eraser, and everywhere I see an n, I replace it with the value that I found for n, which was 16 over the square root of 2. So I replace this n here with 16 over the square root of 2. So now I can say that x is equal to 16 over the square root of 2, and y is equal to 16 over the square root of 2. Okay, let's try it one more time. In example 2, and I'll have you do example 3 on your own. All right, example 2. Now they don't say it's a 45, 45, 90 triangle, but they do give us two congruent sides. So if we have two congruent sides, this is an isosceles right triangle. And remember, an isosceles right triangle, there's 90 degrees left to split between these two angles. So 90 divided by 2 gives us 45. So each of these angles is in fact a 45-degree angle. Now that we found the measures of the angles and we know that this is a 45, 45, 90 triangle, we label each side as n, and n square root of 2. So the side opposite the 45 is n, side opposite the 45 is n, side opposite the 90 is n times the square root of 2. Our next step is to locate the side that has a number next to it. So our side that has a number next to it is 8 and also 8. Use that side to solve for n. So our goal is to get it to say n equals. And in this case, it already says n equals 8. So now, last step, we replace every n that we've put down in our problem with the value that we found for n. So everywhere we see an n, we erase it and replace it with the value we found for n, which is 8. So in this problem, x is equal to 8 times the square root of 2. Okay, now I'd like for you to give it a try. If you follow these steps carefully, you're sure to get the right answer. Let's pause the video and see if you get what I get for number 3. Okay, and you should have gotten x is equal to 12 over the square root of 2 and y is equal to 12 over the square root of 2. If you didn't get that, try again by following these steps, or ask a neighbor, or raise your hand and ask me. Okay, and the last special right triangle that you need to know is a 30, 60, 90 triangle. And that's when you have a right angle, a 30-degree angle, and a 60-degree triangle, or angle and a triangle. In a 30, 60, 90 triangle, the hypotenuse, so the side opposite the right angle, is going to be twice as long as the shortest leg. So the shortest leg is opposite the 30-degree angle. And the longest leg opposite the 60-degree angle is going to be the square root of 3 times as long as the shortest leg. So let's put that in variable form, just like we did with the other one. We start with the shortest leg. We call it t. And the reason we use a t this time instead of an n is it helps us to remember that t for 3 because there's 3 different angle measures, 30, 60, 90. So I call the shortest leg t. The longest leg opposite the 60 degrees is square root of 3 times as long as t. And then the longest side, the hypotenuse, is twice as long as t, the shortest leg. So another thing that you're going to have to remember is that we use the square root of 3 this time instead of the square root of 2. And the way we remember that is that there's 3 different angle measures, so it's the square root of 3. Okay, the steps for solving a 30, 60, 90 triangle is similar to a 45, 45, 90, except we're going to use the variable t, and we're using 3 different terms. We label each side as t, t square root of 3, and 2t. So opposite the 30 is always our t. Opposite the 60, once we find our missing angle, 60, opposite the 60 is t square root of 3. And opposite the 90, our hypotenuse is 2t. We label the hypotenuse 2t. Now we know to locate the side that has a number next to it. So x is not a number, y is not a number, 12 square root of 3 is our number. And we want to use that side in order to solve for t. So we want it to say t equals. That's our goal here, is to find t. And luckily this already says t equals. And t is equal to 12 times the square root of 3. Now we want to replace every t that we see with the value that we've found for, let's change that to a t. So everywhere we see a t, we replace that t with what we said t was, 12 times the square root of 3. So I'm going to put the t in parentheses here because I'm going to have to distribute. So x equals 12 times the square root of 3 all times 2. So I do 2 times 12, which is 24, times the square root of 3. So that equals x. All right, and down here I need to erase my t and replace it with what I found t to be, 12 times the square root of 3. Now this one, we have 2 square roots of 3's back to back. So this equals 12 times the square root of 3 times 3, which is 9. And the square root of 9 is 3. So this becomes 12 times 3. And 12 times 3 is 36. So that's what y equals. So finally we have x was equal to 24 times the square root of 3, and y was equal to 36. Okay, so let's try the first example. Our first step is to label the sides t, t square root of 3, and 2t. The side opposite the 30 is always called t. The side opposite the 60 is always called t square root of 3. And the side opposite the 90 is always called 2t. So remember, our goal is to find the side with the number next to it, and that is the 15. Now the equation that's set up here, it doesn't say t equals, so we have to solve for t. So we have the equation 15 equals t times the square root of 3. So in order to isolate our t, or to get t alone, we want to divide both sides by the square root of 3. So we get t equal to 15 over the square root of 3. And now our last step is everywhere we see a t, we're going to erase it and replace it with 15 over the square root of 3. So here's a t, I'm going to erase it and replace it with 15 over the square root of 3. And here's a t, so I erase it and replace it with 15 over the square root of 3. Now here we have a fraction, and all we do with a fraction is we multiply our numerators. 2 times 15 is 30, and we leave the denominator over the square root of 3. So y in this problem equals 30 over the square root of 3, and x in this problem equals 15 over the square root of 3. Okay, let's try it one more time with example number 2. Remember, our first step, this is a 30, 60, 90. Our first step is to label each side as t, t square root of 3, and 2t. Opposite the 30 is always called t. Opposite the 60 is always called t times the square root of 3. And opposite the 90 is always called 2t. So our goal is to find the side that has a number next to it. So that's 11. After we find the side that has a number next to it, we want to solve for t. In this case, it already is in the form t equals a number. So t has already been solved for us. So now it's erase and replace. Everywhere we see a t, we want to erase it. Oops, that equaled t square root of 3. I just wanted to erase the t. And replace it with what t equals, which is 11. So y equals 11 square root of 3. Okay, over here we want to erase the t and replace it with what t equals, which is 11. So we're doing 2 times t, which is 11. So we're doing 2 times 11, which is 22. All right, so our final answer is x is 22 and y is 11 times the square root of 3. Okay, so make sure you follow the steps one by one for number 3 and see if you get what I get. Go ahead and pause your video. Okay, so you should get x equals 8 and y equals 8 times the square root of 3. If you didn't get that, follow the steps again and try again. Raise your hand or ask a neighbor. Okay, the second half of the notes will be completed on a video labeled Part 2 in the folder.